Okay, I've done portfolio, modern portfolio theory before on Excel, but I thought about this and I thought of a way to do this a little bit quicker and show you more interesting stuff on modern portfolio theory. I'm going to show the efficient frontier. I'm going to show things like the capital allocation line, how to use solver to find to optimize different things on your portfolio. So without further ado, let me just get started. Hopefully this video will be interesting. So we have to do a start date. So I'm gonna go equals today, minus 365 to go 1 year back. For end date, I'll go equals today. Okay. And then we'll just we're gonna use a stock history from the built-in stock history function on Excel to go ahead and get some stock price data. So I'm gonna go to stock, comma, start date. I'm gonna absolute reference that. And then the end date, and I'm going to absolute reference that. And so now we have the close. Now this is quick and dirty. I recommend using adjusted close like from Yahoo Finance. But we're just because adjusted close, like Apple pays dividends, and right here you can see that it's not folding dividends into the prices and all that. As of October 2024, Excel doesn't have adjusted close. Hopefully someday they will. All right, so, but just to demonstrate this, so you know how to do this, assume this is adjusted close. I'm going to go copy, and I'm going to paste it over here. And this one, I want to make sure it points to this. So I'm going to drag it over to John Deere. And then I'm going to get rid of the dates. So in order to drop the dates when it downloads, it's already have the dates over on the left. I'm going to do 3 commas and a 1. And then let me drag it over one more time to get Google. So now we have the price history on all the, for 3 different stocks, right? Obviously you want to have stocks that have positive returns over the period that you're doing. It'll actually make this come out a little bit better. Well, maybe not obviously, but you should try. I mean, if you want it to come out the way it's coming out here, you want to use stocks that have positive returns. I already checked before we did the video. This has positive returns. And so we're going to save some time. I wrote these Lambda functions, and you could put them in one at a time. Like if you go up here to name manager, you could add each one of these in. I could go new, and I could put them in each one at a time. But I suggest to use this. If I go to my home screen, you see I have this Excel Labs. And the way you would get that is you would just go to store. When you get to store, we type in store, you want to go browse add-ins. And then we want to look for, if you just type labs and enter, and you want to look for this Excel Labs, a Microsoft Garage project, and go add. You go add, then this little test tube will will turn up on your home screen. Okay. So I already have mine there, so I'm just going to go ahead and click on it. And I'm going to go to modules, and I'm going to go new. And we'll just call this module portfolio. And I'm going to go add. And then I'm going to go back to here. I'm just going to copy all this. Now I'm going to go ahead and I'll put this on the video. I'll put it under the description or in the first comment, because this is just text. So you can do the same thing. You could just paste this into your Excel. So I'm going to go copy. I'm going to go over here. I'm just going to paste it in. And it puts those in there. And it's not going to appear yet. If I go over here to the name manager, go to formulas and go to the name manager, you can see it's not there. But if I hit this little save button, now if I go look in the name manager, put all those functions in there. And you know, we named it portfolio, so it's portfolio dot, and then that's the name of the functions. All right, so now we can use them. So now we can do things like, we can do like, we could calculate like the average returns, right? And so if I go here, I go equals portfolio. If I start portfolio, all those functions I just all those functions we just imported it right here because we started them in the portfolio. And the one we want is we want the portfolio expected return is what the average is. So if I do that, and it asks for, well, not portfolio, I'm sorry. We want, not portfolio. We haven't formed a portfolio. We want the portfolio, let me look here. See, we have portfolio expected return and expected return. So we want expected returns. But it asks for the prices. So I could highlight these prices, right? But if I'm going to hit escape. Instead of highlighting them, I'm just going to highlight them right now. I can name them anything I want, but I'm going to call them P for prices because that's the way those lambda functions are. And so now I can go in here again. I can go equals portfolio. And we want portfolio, not portfolio expected return, but not the double portfolio, but just the expected return of these, right? Now if I double click that, and then I go P, and since I highlighted these and called it P up here, you can see that it highlights them for me. And if I just hit enter, it puts those in. And then we could also do the standard deviation of those returns. And so I can go equals portfolio again. And then we want the standard deviation of the returns, and then also P again, and it puts the standard deviations. So let me highlight those and I'll make them all percent. And by the way, I didn't use log returns here. I just used a simple that divided by that minus 1. If you wanted to, you could go in there and adjust my lambda function very easily. You could go in here into name manager and go where we do where it says periodic returns. If you edit this formula, you could put natural log in there and that would work. But I'm not going to get into that. All right, so this is just regular periodic returns. Again, you get the idea no matter what you use. Now I'm going to do something called the Sharpe ratio. So I need to put the risk-free rate in here, and this is going to be the daily risk-free rate. So I'll call it 0.0175% per day. Okay. So we'll just give some kind of risk-free rate here. Yeah. So now we can do the Sharpe ratio. Yeah, so that's going to be equal to parentheses the average return minus this risk-free rate, and I'm going to go ahead and F4 that because I'm going to copy it across, divided by the standard deviation. And this isn't a percent, of course, it's just a number. Let's take it out one more place. And then we can copy that across. And let's go ahead, just for reference, I'm going to go equals whatever this was, just so we have a reference of what we have. So now we have our descriptive statistics for our individual securities. So the expected return for Apple, John Deere, and Google. So they all have positive returns. That's good. So this is the return, and this is the risk, right? The standard deviation is the measure of risk, and this is the amount of return per unit risk. That's basically what this is. The amount of return the amount of return in percent for every percent return of standard deviation, which is my risk. Okay, so this kind of compares the two. So the highest Sharpe ratio, the Sharpe ratio is kind of join these two, right? Because you can look for the least risky or the best return. Well, this kind of measures them both together, which is kind of nice. Okay, all right. So now let's form a portfolio. So I'm going to go my weights, and what I'll do is I'll say equal. I'll just mindlessly put 1/3 of my money into each. Not without any thought. I'm just going to put 1/3 of my money into each one of these stocks, right? And so if I sum that should equal 100%, right? And let's go ahead and make this percent because it's a little bit easier to read. Okay, so if I had like $10,000. I would invest dollars invested would be equal to, of course, this F4 times this. So I would do I'd buy $3,333 worth of each one of these stocks. So if I sum that, just to double check again, I like to put double checks in here. It's $10,000, right? So that should be equal to that. And then the number of shares of each one, well, it'd be equal to this divided by, and we'll just use the price the price of the stock. I'm recording this on 10/3, right? And so the close at this price today. Okay. And this is, of course, this is the number of shares, so that's going to be a number. So this is how many shares of each stock I would buy. Okay. So now we kind of know what's going on. And so now let's calculate, if I do this, if I put a third of my money into each one of these, and I buy this many shares, well, what would be my, so now we can do some portfolio statistics. So we can go to the portfolio expected return, or average return, same thing. And so that's going to be equal to portfolio. And that's where I'm going to use the double portfolio expected return. And that asks for the weights. Now, again, I'm going to hit escape because I'm going to use the weights a lot. So I'm going to highlight these. I'm going to go up here. Again, I'm just going to say W for weights. I could say any letter I want. So, but I use W because it just kind of makes sense here. So I'm going to go equals portfolio expected return. And then W, it highlights those, and then P, it highlights those. Now, if I would have called that Z, it still would have highlighted those and still would have worked. But I'm just using W and P just to... And then we can do the portfolio standard deviation. And that's going to be equal to portfolio standard deviation. You know you're doing a portfolio calculations because it's asking for the weights, right? I double click it. See how down below it asks for the weights first. And I called the weights W, so that just kind of makes sense. And I called the prices P. And again, we're going to calculate the Sharpe ratio. Just let me copy this and paste it. And they'll do the same. And then we can go ahead and highlight these. And we can do format painter. Format them all the same. So now we have the, let me put the formulas in here just so you can see them. And this is the daily, right? These are daily returns. This is based on daily information. This formula actually lives. This formula actually lives over here. This is a spilled array. So the formula lives over, whoops. Lives over there, right? It lives in this first cell. See, when you click on it, you can see it's a spilled array because it does that. All right, so now we can see. So let me do some highlighting here. So I'm going to highlight this. I'm going to go conditional formatting. I want to say if this is less than my portfolio return, I want to make it a custom format. I want to make it, I want to fill it with a dark red because I don't want to look at it. Okay, so in that case, my portfolio didn't outperform, as far as expected return, it didn't outperform Apple or Google. And then we're going to do the same thing here. I'm going to go here, I'm going to go conditional formatting and highlight cell rules. So if the risk is greater than, it's not going to outperform. So I'll go greater than this. Again, I'll make it custom format, dark red. So just by mindlessly diversifying and putting a third of my money into, you can see that my risk is lower than the risk. Remember, lower is better. None of these stocks would be better than 0.0151. And let's do the same thing with the Sharpe ratio. I'm going to go conditional formatting. So if it's less than that Sharpe ratio down below, it's not good. Again, we're going to go custom format, dark red. Okay. And so this Sharpe ratio is less than that. And well, hold on, that didn't. 0.064. This should be red also. Let me check. Conditional formatting, manage rules. Close. Let me do this. Conditional formatting, manage rules. G13. G14 and G13 is this. Okay, so this rule I made some kind of mistake. Let me delete it. Let's try that again. If these, conditional formatting, highlight cells rule, if any of these are less than this, then we want to make it red. Okay. All right, so the Sharpe ratio, like again, the Sharpe ratio, the only place the Sharpe ratio is better is an apple. Okay, so you can see that the portfolio outperform, because if it's red, the portfolio is better, right, than any of the red numbers. All right, so now the question is, so let me just copy this down just so we have a copy of it. So I'm going to go copy and paste it down here. Well, I'm going to paste it as values because I don't want to lose anything. And then I'm going to say this is equally weighted. Just to have a copy equally weighted. This way we have a copy of it because I'm going to form several portfolios. So now we could say, well, can I do something better? So how about if I want to maximize the Sharpe ratio to get the highest Sharpe ratio possible? What weights could I do here to do that? So I can use Solver for that. So I'm going to go here. I'm going to go into Data. I'm going to go to Solver. And then Solver, in order to get Solver up, you can Google on how to turn Solver if you don't have it here under Data. It's very easy to do. So what I'm going to do is I'm going to set this Sharpe ratio to a maximum by changing these weights right here. Okay, I have to add one constraint. I have to say this equals, I'm going to spend all my money, so that has to equal to 1. And I'm going to go, okay, 1 is 100%. I'm going to leave that checked, leave everything as a default, and if I go solve, then okay. So now I changed these, right? Now you can see, now my Sharpe ratio is 0.072, which way outperform these very well. My risk is much lower than these, and the only return that was outperformed that outperforms it is Apple. So I'm in a much better situation here just by, and these are the weights I would use. I'd buy 31 shares of Apple, 2 shares of John Deere, and 12 shares of Google. Now remember, this might seem like magic, right? Because this is based off history. So you don't know, putting these weights doesn't guarantee you the same thing is going to happen in the future, right? Also, I use daily. If you use weekly, you're going to get different results. Monthly, if you don't go back as far. So this is just showing you, but basically what this is showing is the power of diversification, and balancing your portfolio the right way can really affect how things happen. All right, so let me copy this down because I'm going to do some other ones. I'm going to go copy. Let me paste it here. Paste values. I'm going to put a space here too, just to give us a little bit of room. All right, and this one was, we'll call it maximum Sharpe ratio. Okay, let me just highlight these just to kind of make it look a bit nicer. Let me make it like light blue. Okay, so how about if we want to have the least amount of risk as possible? Okay, so the least amount of risk, what I could do is I can go ahead and go back to Data again, and then go to Solver, and I could say, well, let me just reset all just so you see how this is done. Reset all, and what I want to do now, I want to minimize my risk, which is the portfolio standard deviation, again by changing these weights. Okay, and I'm going to add the constraint that this, again, don't forget to do that, equals 1. Okay, Now this just makes sure that none of these go negative, that you don't short anything. Let me go solve, and then okay. So my minimum variance portfolio would be this. This is the least risky. You can see that this risk is way lower than these three risks. Okay, so let me copy that down. Copy. Let me just put it here. Paste values. So this is the minimum. Okay. All right, so we have a lot of, let me see if there's anything else we might want to do. If you try to maximize the return, well, it's just going to maximize onto Apple, right? So that's probably not, that's kind of a trivial thing to do. But what we could say is, okay, what if I, what's going on here? Let's graph this and see what's going on. So what I'm going to do is I'm going to go here, and I'm going to say, let me do it here. I'm going to say equals rand array, and we're going to go 1 row and 3 columns, right? And then I'm going to sum that. So I'm going to go here to auto sum. And then what I'm going to do is I'm going to do these weights based off these random numbers. But I still want to equal 1. So I'm going to go here. This is equal to this divided by this. And I'm going to go ahead and F4 that total. And then if I drag that random number across, so now it's always equal in 100%. So every time I hit F9, it'll recalculate. And I'm getting all these random portfolios with different expected returns and standard deviations. Okay, so I'm just randomly generating portfolios. So I want to do that because I want to generate a lot of data points with different weights. So let's go ahead and so now what I'm going to do is I'm going to go over here. I'm going to go trial. Let me do it down one more down. Trial. I'm going to go 1. And what I'm going to do, generate several trials. So if I go here to fill, series, columns, I'm not going to go crazy. Let's just do 2,000 trials. So that'd be like hitting F9 2,000 times. And then we'll put, here I'm going to put the portfolio standard deviation. And here I'm going to put the portfolio expected return. So here I'm going to go equals portfolio standard deviation. Oop. Let me try that again. So equals the number for the portfolio standard deviation. And here equals the number for the portfolio expected return. We'll put the weights here, so this equals these weights. Just to keep track of them. We don't have to, but kind of nice to see the weights. So this is equal to those, right? I'm going to go weights. Okay, so every time I hit F9, again, those are going to change. And those are all those numbers I'm changing. They're just kind of copying across from whatever there was on the left. But here's the magic. I can take this. I can highlight all this. And then I'm going to scroll back up. And what I'm going to do is I'm going to go to data. And then what if analysis data table. And since this is in columns, I'm going to go here. And the trick is I'm just going to hit on a blank cell and go OK. And let me just format all those the same. Okay, so now we have that's like hitting F9 2,000 times. So let's just graph what's going on. So I'm just going to graph this much stuff right here. Scroll back up to the top. And we're going to insert a scatter plot. And there we can see I'm going to get rid of the title. We don't really need that. And let's just make those dots a little bit smaller. So I'm going to format the data series. And I'm going to go in here to markers and marker options built in. I'm going to make those as small as possible. Also make them something that doesn't stick out so much. Okay. And then let's just go ahead and make this graph a little bit bigger so we can see what's going on. So you can already see this is called the efficient frontier, this little border. And all these different dots are different portfolios of those 2,000 portfolios. That's all of them right here. Okay, you're gonna get different shapes depending on, but normally you're gonna get something resembling kind of a parabola. So we can just let's start labeling this just so it makes a little bit of sense. So I'm gonna add some. So I can go add chart element, axis titles, primary here horizontal. So I'm gonna go equals. So the horizontal is the portfolio standard deviation, right? Let's see if it took that. Nope, it didn't take it the way I want. Let me try that again. Click here, and then we're gonna go to chart design, add chart element, axis titles, primary horizontal. I'm gonna go equals portfolio standard deviation. Right. Okay. Wait to try it one more time. Axis titles, horizontal, equals portfolio standard deviation. And try it again. Axis titles, primary vertical, you go equals portfolio expected return. So now I have those. And so you can add some of these things here. Like we could add just the individual securities. Well, no, let's just add some data here just to show you how cool this is. So we can do I'm going to go select data, and this first series, I'm going to edit it. And what I'll call this is just random portfolios. Okay, randomly weighted portfolio. Okay, and then I'm going to add another one. And what I'm going to add is I'm going to add Apple by itself. And the X series for Apple is a standard deviation, which is this right here. Remember, the standard deviation is on the X. And the Y, now you have to delete these. You just can't highlight. You have to delete it. And the Y is the average return. I'm going to go OK. So you can see that one right there is Apple. Okay, and see how I put a little orange dot there for you? And what I'm going to do is I'm going to put the legend here. So I'm going to go add chart element, legend, and we'll put it on the bottom down here. So it's showing here the little dots are the random, and an apple is this one. And that kind of makes sense because Apple is the highest return. So of course that would be the highest. Just Apple by itself, 100% Apple would be right around there somewhere, right? So let's add some more points. So I'm going to go to select data. And we'll go add. Let's add John Deere. Remember the x-axis is a standard deviation, and the y-axis, delete this out of here, is the average return. And you can see it puts John Deere down here, and that makes sense that John Deere is the lowest return. 0.1 in the standard deviation, 1.424 is about right there. Okay, we can add. Let's go ahead and add in Google. So the series name of Google. So I'm just going to go click on Google. The X series are the standard deviation, and the Y series is the average return. And then we have Google. So those are my three securities. And anything in between is where randomly, any other random portfolio is going to be landing in there. Now, some other things we could add. We could add some other things that we put here, like we did maximum chart ratio. And that's a special, I'll show you, that's actually a very special, the reason I did that, it's a special point on our efficient frontier. So I'm going to go ahead and add that in. So again, I'm going to go select data and add. And the series name is maximum Sharpe ratio. And the X values for that is this standard deviation, and the y values are this return. You can see that's this right here. Okay, and let's go ahead and add the minimum variance portfolio. That's also kind of an important point. So that's going to be a minimum variance portfolio, and the x values are this, and the y values are right here. So now we have the minimum variance portfolio here, and it's nice we have the legend down here if you forget which one each one of these are. Okay, and I'm going to add one more. Whoops, let me add one more thing. I'm going to add the risk-free rate. So I'm going to go add risk-free rate, and the risk-free rate is going to be zero on the x because there's no risk, and the y is going to be this per day. So the risk-free rate is going to be over here on the 0x because there's no risk, right? The standard deviation is the risk. Now, so now you can see lots going on here. Let me just make this graph a little bit bigger, just so I can explain what's going on. So this is called the efficient frontier from this minimum variance portfolio up. At this point, it's called the efficient frontier because, like, say if I went, remember this green dot is John Deere. If I invested in 100% John Deere, well, this is the level of risk. I could go straight up almost all the way up to right here to Apple, and for the same amount of risk, I can invest in Apple. So why would I do that? Okay, so any point along here below this minimum variance, at any point I could go straight up and get a higher return for the same amount of risk. So why would you take less? You'd want to hire, if you're a rational investor, you're not going to take less return for the same amount of risk. So you'd always go up here from this minimum variance portfolio along this edge right here. So this purple one is the special one where we did the maximum Sharpe ratio. So I could actually jump off of this efficient frontier by doing something called a capital allocation line. So let me do this. I'm going to draw a shape here. I'm going to draw a line. So if I draw a line from here, tangent to that Sharpe ratio, that's called the capital allocation line. So now this becomes my efficient frontier because I'm jumping off there. So I can do, if I did 50% of my portfolio, if I did 50% of my portfolio in risk-free, and the other 50% into these weights. So I did $10,000 or $5,000 invested in this, which would be half the number of shares here, and another $5,000 invested in my risk-free, which would be like a treasury or something. Well, I'd be exactly halfway down in this line, so I jump here. Okay, so I'd be jumping from this efficient frontier to that. Also, I could short this portfolio and come out here along this line. So that's called the capital allocation line. So anyway, I hope I didn't miss too much. I'm just kind of rambling on here, but I'm basically showing you what, Sharpe won the Nobel Prize and Markowitz won the Nobel Prize for modern portfolio theory. So in this short time, 33 minutes, I basically showed you what two Nobel Prize winners were talking about, right? So Excel, back when they were doing it, they didn't have Excel, so it was a lot harder. But anyway, I think hopefully that makes sense. I think I'm going to stop there because I've already gone on for 33 minutes. But like I said, these Lambda functions, I'll put them down in the description if you want to try to do your own portfolio. Hopefully that kind of makes sense what's going on. This is like I almost covered a semester of portfolio theory in 33 minutes, so that's not too bad. So anyway, thanks for watching. If you haven't subscribed to my videos or to my channel, my picture will come up. If you click on that picture, it will subscribe you. If you like my videos, give me a thumbs up. That always helps me, encourages me. Make me any comments if you have any questions. I probably missed some things. And thanks for watching. That's it for today. Bye-bye.